Hello everyone, so in this video we want to draw the correct Lewis structure for this molecule here. So the Lewis dot structure is a representation of a molecule including all the atoms, bonds, lone pairs, and formal charges. It basically represents all the valence electrons in a molecule. So to draw the correct Lewis dot structure, we have to first calculate the total number of valence electrons. So carbon has 4 valence electrons. Hydrogen has 1 valence electron. Nitrogen has 5 valence electrons. Then we have oxygen, and this has 6 valence electrons. So the total number of valence electrons, we can go ahead and calculate it with this provided information here. So we're calculating for the total number of valence electrons in our molecule. So if you count the number of carbons that we have, so we see 1, 2, 3, and 4. So 4 times 4. So one of these 4s represents that we have 4 carbon atoms in this molecule, and then we have 4 valence electrons coming off of 1 atom of carbon. So we do 4 times 4. Then next we can go ahead and count our hydrogens. I see a total of 9 hydrogens, and each will provide 1 valence electron. Then we can go ahead and count the next one, being nitrogen. I can see we have just 1 nitrogen atom right over here. So that's just 5 times 1. And lastly, for our oxygen, I see only 1 as well. So that's going to be 6 times 1. So putting this into my calculator, I get a total sum of 36 valence electrons. So now, next step is to draw the single bond structure of this molecule. So we are given this compact formula here, so it makes it a little bit easier for us. So starting off our molecule, we have our terminal CH3 group. So that's 1 carbon with 3 hydrogens connected to it. Then we have a central carbon with 2 hydrogens, followed by another carbon. So we see we just have a carbon and oxygen, so that will give us a double bond oxygen there. So a carbonyl functional group. Then it's connected to a nitrogen. I apologize, we are doing the single bonded version first. So we have a single bond oxygen, single bond nitrogen with a proton there. And then following the rest of the molecule, we see a CH3 group. So that's another terminal CH3 group. Same thing on the other side of our molecule. All right, so now that we have the single bond structure of the molecule, we can go ahead and now complete the octets by adding the lone pairs and double bonds. So carbon usually likes to have 4 bonds, so it's usually a central atom. Oxygen likes to have 2 lone pairs and 2 bonds. So we see here if we add those, now this central carbon, or the carbonyl carbon, will have fulfilled its octet, as well as this carbonyl oxygen there. As for our nitrogen, this has 3 bonds, and it does like to have 1 lone pair, and we see now that the nitrogen does have its octet being filled. As we recall, hydrogen only needs to have 2 valence electrons, so it requires only just 1 bond because of the duet rule. So we can go ahead and add formal charges to atoms if the total number of valence electrons are not equal to the sum of the bonded pair of electrons and lone pairs. And to calculate formal charge, let's go ahead and write this formula out. So we can shorten formal charge to just Fc. So the equation for that is we take the number of valence electrons of the atom minus the number of electrons in lone pairs plus the number of bonds that it's forming. And that gives us our equation to calculate our formal charge. But as the question is asking us, is to draw the correct Lewis structure for this molecule here. What I have highlighted just now in blue is going to be my final answer for this Lewis structure for this compact molecule there.